All right, welcome there, polynomial function fans. MCT4C day 43 is lesson 5.5 on solving problems involving polynomial functions. And the 3-minute review here is review of, this is a grade 10 example. Typical example, hopefully you read it and tried this yourself. What type of function is this? Well, it's a degree 2 function. It's a quadratic. If you said parabola, that works as well. And calculate h at 2. Well, h at 2 is however we'd like to do this. We practiced the other day a number of ways of evaluating polynomial functions, but probably just putting this into a calculator exactly as it appears in one step, you get, hopefully, 35.4. Interpret what your calculation means after 2 seconds. The ball is 35.4 meters in the air. That's what it means. And then it asks us to use graphing technology to find the maximum height and how long the ball is in the air for. So we'll do that. And this is all review, I hope. We've sort of been working on this the last couple of days, I think. The function is negative 4.9x squared plus 10x plus 35. And when I first graph it, I'm going to have some strange window settings. I might try zoom standard and hope for the best, but I know it's not going to work because the y-intercept of 35, and it goes up to 35 after 2 seconds, the standard is from 10 to 10, and that's not going to work. So we need to go up a little bit higher. And this is kind of like a trial and error business here. Maybe go up by 10s each time. That doesn't look too bad. Find the maximum height of the ball. Maximum, left of the maximum, right of the maximum. Remember, I can type in values if I don't want to use my scroll buttons. And then a guess. 1.2 and 40.1, 1.02 and 40.1. Now, what is that's the maximum? Or sorry, this is the maximum of the parabola. What's the maximum height? A little sentence is it's the y value, right? How long the ball is in the air for? Well, if I look at the graph, the ball goes up in the air for a little bit and then falls down, and then there's a height of 0. Right there, we want to find the 0, right? So how long is the ball in the air for? We want t so that h at t equals 0. I'm going to use the 0 function. Certainly, we could try and solve that some other way, but I got the calculator. It's all revved up and ready to go. Calculate not value, calculate the 0. And again, this is the same sort of thing as the maximum. I go to the left of the max, or sorry, of the 0, and then scroll to the right or enter a value to the right. Went off the screen there, doesn't matter. And then a guess, that's pretty close. And 3.88. So 3.880 is the 0. So the ball lands in 3.88 seconds. Good. That's a review of yesterday. Basically, this is today's stuff too. In a way, we're going to be using technology to solve problems, just like this one. Solve problems involving polynomial functions. That's what we just did, didn't we? We've got a mining town of Brighton, founded in 1900. Its population in hundreds is modeled by that equation. Nasty equation. It's a quartic, right? It's a quartic. Degree 4. M's and W's, right? That's what we're thinking for a quartic. And since it starts low, that's it right there. It's an M, right? Starts low and ends low, something like that. So this is a pretty crazy town, I guess, as far as its population. What was the population in 1900? Well, that's when t was equal to 0. And notice when t was equal to 0, p at 0, that's going to be 0, 0, 0, 0. It's just 7. Now notice that 7 is in hundreds, so the population was 700. What would the domain be in this situation? Well, if it started in 1900, probably anything before that wouldn't make any sense. So, P is the years since 1900. Probably t has got to be greater than or equal to 0, right? Because that's 1900 and then on. Now, what I'm wondering or worried about is, this graph, if it goes down like this, whatever it might look like, I know that that's 700, right there, 7 in 1900. This doesn't make any sense for a population to be negative, and so we wouldn't allow that. And without graphing technology, this is really difficult to do. So the first thing that we're going to want to do is graph this. Then we'll maybe graph it, answer this question, and then come back to B. So let's get that going. I'm going to actually pause the video, type this bad boy in because it's a big long function. You don't have to watch me do that, and then we'll get back at it. All right, there it is. It's pretty nasty. I hope I never made any mistakes. Of course I did. Forgot the plus 10t term. Check that over before I put that in there. Okay, so there's the function. And now I want to graph it, but I could have all sorts of crazy output. I don't know, right? So what am I going to guess at? Well, I know we didn't want any negatives, so maybe I'll go negative a couple just so we see a little bit. But then after that, how many years is this model going to be good for? That's kind of the question in B. Well, I don't know. Let's say 20 years to begin with. But then how high does it go? I know it starts at 7. How high does it go? Will it go to 50? That was the one from last time, and we know we don't want to see it negative, right? So maybe I'll go -2 just so I can see the axis. And will it go as high as 50, 100, 5,000 people? Maybe. Okay, well, let's press graph and see what's going on. So it got chopped off, and I don't need all these x values. So I'm going to change my window settings. I don't need to go up to 20. And just the thing that I said happened, didn't it? This model is going to go into the zeros. So something strange is going on here. And then I said that this needs to be higher, so maybe I'll go to 80. There, that looks pretty good. And so I can see this, the mining town, as the mines are getting bigger, the population's going up, reached a maximum, after so many years, and then it, maybe the mine closed and everyone moved away. And then notice that the model goes into negatives, right? But it doesn't make any sense for us to model that. So when it says to describe the population since 1900, well, I'm going to do a sketch of that model. Well, actually, you're going to do a sketch of this model. I'm just going to copy it because I can cheat. And so there. Right. And in this description, I'm going to go back and also talk about B again. I'm going to want to find the maximum, and about what time, how many years along that was, and also when it became negative, because that doesn't make any sense. I'm going to find those two things using the graphing calculator. I'm going to go second calc, find the maximum, and we're old hats at this now. We're very, very good at it. Left side, right side, and maximum is 5.1 and 67. So get my pen out again. That point right there is 5.1 and 67. The other point I want is that one right there, because that's when the population reaches zero again. It becomes a ghost town. Left doesn't matter, and then scroll to the right of the zero. And if you knew how far to go, you could just type it in. Notice my y values are in the negatives now. Press enter. Then I got to go back in between them for a guess. And I get pretty close there. That's going to be pretty good. I get 7.4 or 7.5 about. And notice, and maybe you've noticed this before, it doesn't say 0, but that's in scientific notation. That's 9 times 10 to the exponent negative, I don't know, negative something, really, really small. So that's 0. 10 to the exponent negative 11 would be that many zeros, and then a 9. It's going to be 0. All right, so now let's describe. This is a sentence. So what I'm going to say is that the population increases until a maximum of 6,700 in this is the number of years since 1900, 1905. Steadily until a maximum of 6,700 in 1905. After that, population decreases quickly until, well, it becomes a ghost town, right? In mid 1907, right? So over here, the model's only good until about 1907, right? So we could say, what would the domain be? Well, we know it's got to be greater than 0, but maybe it's less than 7.5, because after that, the population would be negative and the model doesn't make sense. All right, going to pick it up, example 2 in part 2.